Have you imagined how do apps like Uber, InDrive, Foodpanda or Amazon actually build navigation like this? Not just showing pin on a map. I'm talking about real road navigation, smooth moving vehicles, live remaining distance, place search, and that premium map experience that feel completely professional. Most Flutter tutorial stop after showing a simple map marker, but real old apps are far more complex. So in this video, I'm going to build not one, not two, build the three complete map integration in Flutter, which is currently available is in the market. If you want to use map feature in your Android iOS app, then these three will be the best alternative for you. We'll start with the Google Map, then build the same feature using OpenStreetMap, and finally Mapbox. So by the end, you will know exactly which one is the best choice for your next project. Among these three alternatives, OpenStreetMap is totally free and open source. Mapbox provide free of cost until 25k active user, and Google Map provide you the 300 credit per month. At the end of this video, you can easily decide which map alternative will be best option for your project. We will implement real place autocomplete, live GPS tracking, route drawing along actual road, animated car movement that follow every turns, remaining distance and ETA, custom marker, Riverpod architecture, and much more. So if you have ever want to build a production ready map experience instead of just flashing a marker on map, this video is exactly what you have been looking for. At the time of AI, basic concept is most important. At the end, you have know the setup part, configuration part, and basic concept to integrate map feature in your project. Okay, let's start the complete video. First, we are going to start from the Google Map. After we have completed, we'll explore the other feature of map that you have seen in the demo, where I'm going to start from the scratch. Here you can see this is my map screen and this is my main screen. Until now, I didn't do anything. We are going to start with from the scratch and complete it with the edge feature that I have demonstrated in the demo. First things, let's start from the package. We have required the 5 packages which we are going to use in our today's video. First will be the Google Map to show the map in our Flutter app, and HTTP API call. We are using it to get data from the internet, Riverpod for the state management, geolocator getting user location, Flutter polyline point. This will be used to draw the polyline between the point. Okay, first let's see the setup part, which is easy, that I have already repeated in my different video. In my previous video, I have instructed you how I have set up. I have shown you in many times, but shortly I will show you how you can implement it in what will be the required. To show the Google Map in your Flutter app, first you need to require the API key. Here you need an API key. Just copy it from here and add it in your Android manifest.xml file. Android manifest.xml file. Here I have added. This is my API key. I'll delete my API key before the video published. That's why use your API key. I will also instruct you how you can get your API key as well. Okay. After that, for iOS, you need to import this Google Map and you need to add this Google Service Provider API key in your app.delegate.swift. Okay, just go to your app.delegate.swift. Best will be the source, or you can get it inside the runner as well. In the main.dart, in the app.delegate.swift, import the Google Maps and add this GMS Service Provider API key. Okay, after that, Google Map integration will be completed for Android and iOS. In today's video, we are only going to cover only for Android and iOS. We are not covering for web and desktop app. Okay, HTTP didn't require any setup to use it, and Flutter Riverpod also didn't require any setup, and geolocator requires some setup, and which is also easy as well. For Android, just add these 2 lines of code in your Gradle property that I have already added. You can see one is default there, and just add this, then it will be done. And in your Android app build.gradle, you need to set your compile SDK version at least 35. I have set it 36. Okay, or you can set more as well, but at least 35 will be required. App, I will show you inside the app folder. Here is my build.gradle.kts, and in compile SDK I have set it 36. Okay, after that you need to add this permission in your Android manifest.xml file. Okay, you need to add this permission to use geolocator, which is the access file location, access is background location and other location. After that, Android setup will be completed. Next, for iOS setup, you need to add this ns location when in use, which is description, this key value pair in your info.files. Okay, inside the iOS folder runner info.files folder, you need to add this file, this key and string to use geolocator. Okay, here everything will be mentioned. Just copy it from here and paste it. After, inside your pod file, you need to add some target builder configuration. Inside your iOS folder, here will be the pod file, and inside your pod file, if you want, you can add this, or if you didn't want, it will be not mandatory here the latest update. Okay, I didn't add anything here in my pod file, but didn't forget to uncomment this platform iOS and set it at least 16 iOS version will be require a different package. And last package will be the Flutter line point. This package didn't require anything. I have saved it all and close all the tabs. Now setup part will be completed here. You can see here I have already created the core folder. Inside my core folder, I have stored my API key. This is my API key that we are going to use in the multiple screen. That's why I have stored it here. And I'll mention this is not the best way to store API key. This is only for learning purpose and only for sample project. That's why I have stored it in the UI part. Okay. Or in the context of Google Map API key, you can also store it in your UI part as well, and Google Map console provide you to restrict the API key. Then first go to your googlecloudconsole.com, create your account and the payment info. You need to add your payment info, but most important things is you didn't need to pay it. Okay, you will get the 200 free credit. From this credit you can easily use until nearly 3000 active user it can handle from the free credit. Okay, after you have login, after you have create account in your developer console, after you have add your payment info, then you have landed here. Okay, after that create, if no any project will be available here, from here you can create the any project. And after that go to this navigation menu, and in API and services, and from the credential you can create the API key. You can see this is my API key. After I have completed this tutorial, I will delete my API key and generate my new API key. From here you can create your API key as well. Okay, at the same time I will also show you how you can restrict your API key from where if your API key is public leaked, then still no one can use it. From here you can restrict. If you can add your app ID, bundle identifier for Android iOS, bundle identifier for iOS and app ID for Android, then other than that at ID, no one can use your API key. API key process will be completed. One thing I will also show you, you also need to enable some API before using it or before creating it. Here you can see it will request in 4 API, place API, direction API, map SDK for iOS, map static API and map SDK for Android. Until now I have not used Android simulator, that's why Android will not appear. I will show you later. Before you create the API key, first didn't forget to enable some API. In the API and services, here is the library will be available. Then you need to enable some library that I have mentioned. First enable the map SDK for Android, map SDK for iOS, map place API and Google Drive API. At least you need to enable these 4 API. If you get any error, then also enable some other API that will be mentioned, and also enable place API new. After that you are ready to use your API key. You have completed everything. Now start to code. Inside my leaf folder, I will create another folder and I'll give name called feature. Okay, inside this feature, I'll create another folder and I'll give name called map feature. Map only. Inside my map folder, I will create another folder which is called provider, another folder which will be screen, another folder which will be WIDGETS widgets, and last folder which will be service, and another folder will be required, which will be model. After that, this is the most known folder structure. Folder structure will be important because it make your code clean. Okay, I'm going to starting from the provider. Before that, first let's display the map here. In the scaffold body, I'll use the stack children Google Map initial camera position. It will take camera position lat long 27.23. I will provide it randomly and 84.45, and I'll set zoom will be 14, and I'll save and I'll restart the app. Restart is also not required. After that, let's start from the provider folder. In my provider folder, I'll create the file and I'll give name called map provider dot. Inside this folder, this is my Riverpod folder where I will code for the logic part, and they create the single instance of each service. From this service we can call and implement each and every feature. It make it available anywhere in the tree. You can easily access it by using ref.read, ref.watch. Think of a provider like a global dependency injection container. We pass the API key from the f constant, so service doesn't hard-coded sensitive data. Here, first things, I will start from the state, and first I will show you, and then in today's video, in the time of era, I will do the less code and I will explain you more. I'll comment it out from here as well. We'll use this feature later, that's why I'm going to comment it out. Here, this map state is a immutable data class. It holds every piece of data the UI needed. And there will be the one question raised, why immutable? Because Riverpod work reactively. Whenever data change, the UI rebuild automatically. And another important thing, it will rebuild the UI that will only require, not totally rebuild the entire UI if something need to be changed. This is the main important things. After that, this all will be used later, and this is a GPS position, and this is when we want to go destination. This is the marker, polyline, route, loading, error, remaining time and distance, okay, and many things. After that, this copy with is the standard Flutter pattern for updating an immutable object. Instead of mutating field, it returns the brand new map state with only the specific field change that I have mentioned. By using this copy with, if we require only this polyline, then without updating and rebuilding other things, we can easily update only one thing. This is the importance and benefit of using copy with Riverpod. Okay, let's start from the notifier. Notifier is the brain of the app. You can know notifier is the brain of the app. It contains all business logic of this app inside this class. It extends state notifier. Okay, I'll start class, and we have required the map notifier, or you can give map provider as well, which extend the state notifier from map state. Easy. It extend map state notifier from map state, which means it owns a state property of type map state. Whenever we set the state, Riverpod notify all listener, which is the listener means widgets, and widget rebuild only when part of the state they was actually changed. This is the view model in MVVM architecture. If you use MVVM architecture, same type of model will be used here. Here, I will define the three things. To use the timer, you need to add dark.async. We have used this map controller to store the Google Map controller, so we can move, zoom the camera programmatically, not default. Okay, from inside the notifier without needing direct access to the widget tree. And this is animation timer. This timer drive the frame by frame marker animation along the route. That's it in one sentence. And this duration, you can see here, I have also mentioned control how long the marker takes to travel the full route. That's it. After that, I'll call the super map state to initialize with a clean empty state. Before calling this super map state to initialize the clean and empty state, we need these three things, which is the place service, direction service, and location service. Before moving forward on the map state, let's first complete the service things. First, I will create the place service dot and I will copy the code and paste it here, and I will make you clear each and everything. This is our place service where API key will be required, and the place service handle all communication with two Google Place API. First will be the Autocomplete API and second will be the Place Detail API, where Autocomplete API convert the search string into the list of place suggestion, and Place Detail API convert the place ID into the real GPS coordinates. Okay, this is the two main important things about the place service. Why two separate API call? If you have confusion about it, the autocomplete API is very fast and return many results from the partial query, but it deliberately omit coordinate to keep response lightweight. Only when user selected a specific place. Without wasting time, get started. What does get suggestion do? Get suggestion is called on every keystroke bounded by location search bar. It returns the list of place result object to populate the suggestion drop down. In simple sentence, this get suggestion return the list of place result that we have searched in the search bar. For that, we have required the place search model. I will create inside my model folder. I'll create another file and I'll give name the place result dot. Inside this place result, we have stored the 5 things, which is the place ID, description, primary text, secondary text, and lat long. If you can only store primary text. If some place are confusing, same place name, but it's might the secondary text can identify in the exact place from where we have display address, area, city, not only the name. After that, we will call this place result in our place service. I have already made it clear what does this is function work. And first, here is the input.trims.isEmpty. Then it will return null. This prevent unnecessary API quota. Use and avoid the confusing empty list. Okay, just like if someone searches z, then we didn't show anything on the suggestion list. By this way, we have limit the request in the API. If you have published app, then we need to also limit the request. If you do anything in the code, then your request will be high and it will be difficult for you to manage the cost. The main things about it, we have handled it here. Inside this URL, here is the URI.parse. Here I do many things. If you are confused, I will make you clear. Build the autocomplete API. We have required the two things, which is the URI.encode component, encode special character. It will encode the special character just like space percentage etc. So the query string is a valid URL even if the user type different things. Just like if user type space, then we will encode it, and this language will be the simple. It will ensure suggestions are written in the English regardless of the device local setting. After that, inside this try catch, in the response, first we have used the HTTP package to get the URL that we have defined it here, and JSON.decode JSON string to the dot map it convert. Here the API return the status OK when prediction are found, otherwise possible status 0 result, invalid result, request denied will be appear. This is the place ID description that I have already mentioned. Why we have used it all, why we have used primary secondary text. If you use primary and secondary text, then it make it easy to identify the place in the world. There will be the many place with same name. By using this detail and secondary text, we can easily identify it. In the catch, we have print the autocomplete error from where we can find out the error if we face. Okay, and here is return empty list. On any error, the UI simply show no suggestion. And here this get lag long is called once when the user tap the suggestion and return null if the API call fails, so the caller can show the error message. Be careful, I will make you clear everything. When we have search, it will show the list of suggestion. When we click this, then when we click any suggestion, then this get lat long is called. Okay, again this URI.parse and this URL is some boring and different. Why it will require, how you can get it, I'll mention. Field geometry is critical here. You can see this geometry field is critical. It's limit the API response to only the coordinates we needed. Without this, the API returned every field, name, phone, website, hours, photo, which is wasting bandwidth and cost the more quota. By this filter, you can easily get that you have required. And remaining all same, this is the response and this is the JSON data. If status is okay, then resolve geometry location lat long, the API return the lat long. This lat long is converted into the JSON and it will return decode. This lat long is again decode and return the place that we have required. And this return null caller must handle null, just like show error of user and convert raw map value to lat long. After this place service, we have required another things, which is the location service. Here we have only do the two things in simple language. First we will get the permission from the user. If user get the permission, then we will directly return its current location. If it will deny, then we will request for the permission from the user and return the null. If user deny permission forever, then only return null and we can get it. Otherwise, if user get permission, then we will get the current position and display the location. From the location service, only ask the user from the permission and you get the user current location. Last things, the service is file content, which is the direction service, where in direction service, name specify everything. We'll use it to draw the route and to get the direction. Here first things will be the route info. Route info is the simple data class model and that handle the three things. When we get back from the direction API into one convenient object, first that things that we have required the polyline, the distance and duration. This polyline, the order list of GPS coordinates that's as form the route line, and this is distance and duration. You have clarify everything. Using the dedicated class, the key, it will keep a return the type clean and safe document. Simply we'll use to draw the route and calculate it and show the distance and the time. And direction service, again we have required the API key and get route. This get route is the single public method. It called the Google Direction API and translate the raw JSON response into the route info object. Raw JSON, when we have start to draw the route, we have written the route info here. What it do? It will convert the raw JSON into the response info object that human can read it. Before that, I'll make it clear here. Here is the many things why we have required this. The API URL with the query parameter. First will be the original and destination, comma separate lat long pair. This original will be the current and lat long and the destination will be the destination lat long. It will be simple. Mode will be the driving. We want a road route, not walking or transit. Okay. Alternative route will be the false currently. Single base route will show the one of the base route, only return the single base route. Faster response, we get faster response. If you want alternative route, then and you can make it enable. This API key is your Cloud Console API key for authentication. Okay. After that, inside this try catch, everything will be similar. We'll get the response from HTTP this get URL, and this is the parsing JSON, and API always return status as field. If okay means we get valid result. If not, then we will get error. This is the API response structure list. Why decoding edge step polyline instead of overview polyline? This is the question. In my previous tutorial, some viewer asked, I'll make you clear. The API also provide the route 0, overview and points, which is one single encoded polyline from the entire route. However, it is heavily simplified. It skips many intermediate point on curve and round bound. This look fine as a static line on the map, but when an animate a car marker along it, the marker cuts corner instead of following the route. That's why we need this point. The car always follow the every curve precisely and carefully. Not go to the direct if the curve, if the road is curved, then if they found shortcut, then if go directly, then there will be no meaning. If there will be the curve, then it follow this curve. Here, each step has polyline object with an point field containing an encoded polyline string. Google Compact from from coordinates. And this route polyline dot decode polyline is a static method. It's convert the encode string into the list of polyline. That's it. And here after that we have extract distance duration from the first leg, distance and the duration. And inside this catch we have return any error message log if it will require. After that service file will be completed. We have nearly completed 30-40% already. After this service file, I'll call this all inside my notifier. Okay, I'll call it here and I'll import it all. Then we will use it here inside our map notifier, where we will calculate each and every logic that we are going to use to implement each and every feature. First things that I have set the controller. It's called from the map widget on map created callback. We save the controller reference so later method can call animate camera. Next we'll get the current location. Here first we'll get the current location of the user. From here we have fetch the current location, which means we always use async await. Async await is used throughout because network call and GPS are async. We always set the is loading true first, so the UI show the spinner immediately when we have clicked the button, then set it back to the false when network is done. Here we have get the user current location that we have called. Location from the location service, we have get the current location. Location service wrap platform permission plus geolocator plugin. It will return null if the user deny permission or location is unavailable, that I have already mentioned. And this is the custom marker for user. Build a custom blue circle marker for the user position. Instead of this manual image, I will draw the marker using the canvas and decode it as a bitmap descriptor. Let's call it app constant. The default zoom that I have set in my app constant, which will be the 15, will my default zoom. Here in my state, we filter out any old current marker first to avoid duplicate. If user tap locate me twice, then old pin is replaced with the new one. And if you confused, this is the spread operator, which is used to merge existing marker with the new one. And this is the pen plus zoom camera to use to the user location. Pin plus zoom the camera to the user location. Okay, first I'll build this marker here. Okay, generic marker builder. I'll explain it later. First, only understand this is the custom marker with a blue circle with you inside this circle that we have shown in the demo. Okay, we have already get the current location. Next things required will be the destination location. When user select the destination, then how we can get and identify the destination location. Here, this is the code for selected destination. First, let's import the place result. It will call when the user tap the suggestion in the search bar API to convert it into the actual GPS coordinate lat long and identify it. Place detail API. From here we can get the place detail. If not, we have so could not resolve place. Now where we have set the blue marker for the current user and we have build a red destination marker. Same canvas drawing approach is blue one, and we have add the destination marker replacing any previous destination pin. Then only we have draw the route. We already know the user current location. If we didn't have it yet, we still place the destination pin and zoom it out, which means during the sorting time, if we have know the user current location, then we will draw the route. If not, then we will pinpoint and show this destination that we have sorted. We will draw the route sometime later. We will draw the route after that. Where here we have first we have get the current location, after that we have get the destination location. If we get current and destination location, then it will be easy to draw the route. In draw route, this is the private method only call internally after we have both origin and destination, current location and destination location. Here direction service call the Google direction API and decode the polyline, and it will return null if API call fail, just like no internet bend API call etc. Other than that, polyline is the blue line draw on the map containing the origin to destination. Polyline ID must be the unique. Okay, every time it will be fine where we have only draw the route once at a time. Okay, This is the color. Width, if you want, you can increase the width of this route, and the starting cap when ending cap, and the type will be the rounded. And where we have show this error in the route info because we have commented out. We have commented out the route info. Let's uncomment it. Then the error will be gone. Now there will be no error. And this feed camera to zoom is used to zoom the camera so the both origin and destination are visible before you start to move. And here we have added the 2-second delay where user can get and see the full route before you start to animate. Now let's start to feed the camera. Here in feed camera, it will calculate the smallest bounding box lat long bound that contain all polyline point and tell the camera to feed that bounding box with padding. This ensures both the start and end of the route are always visible. And start with the first point is both min and max, then expand the box by iterating over every point. Classic bounding box algorithm. Here I will make you one thing clear. Southwest means bottom left corner and northwest means top right corner of the box. The padding, route zoom padding, add space around the edge so the route isn't flush against the screen border. Now we are start to move the marker smoothly. This part is the one of the longest and complex part. Don't worry, I will make you clear everything. It move the car icon smoothly along the route. Main things will be this. It not look smooth, but other than that, the polyline has 100 of lat long point. If we just move the marker from point 1 to point 1, point 0 to point 1, point 1 to point 2 etc., the speed will be uneven because some segments are shorter, curve, and some are longer highway. The result will look jackery. Instead, we normalize all segments into the single 0 to 1 timeline and interpolate position it is 60 fps streak. In normal, if the path is straight, then the marker is moved too fast, okay? And if it will curve, then it is too slow. Instead of showing this, we will make it smooth in each and every route. Okay, something will be mentioned here and something I will make you clear. Starting from the here, animation timer.cancel, it will cancel any previous animation before starting new, and it is the total animation duration in millisecond, total path length in degree. This will be the first steps. And here in the first steps, we will calculate the total path length. This will be our first steps. In second step, we will build the progress list. Here, progress list, cumulative distance at each point and normalize to 0 to 1. This map each polyline point to a fraction of the total journey. It will be starting point will be the 0 and ending point will be the 1. And tick every 16 millisecond. Here, when animation completed, snap to the final point and stop the timer. After the animation will be completed. Here normalize progress 01 that I have already mentioned. Remaining, this is the remaining progress in inverse of how far we have traveled. We have displayed the remaining time as well. And this is for live distance duration countdown. We pass the total distance and duration from the API string, then multiply by the remaining to get the current leftover amount. This gives the realistic countdown even though the marker animation is smooth. This is the format output that we have display. So meter when under 1 kilometer and minute when under 1 hour. If more than that, we have show the kilometer and meter in both. And here we have find which polyline segment we are currently in. We scan the progress list to find the segment where this T falls between the progress I and the progress I plus 1. This tells us which 2 point to interpolate between for this particular animation frame. After that, this interpolate within this segment, it will be difficult for you to understand, but don't worry, at the time of AI can easily do it. Everything you didn't need to do it by yourself. I have also code it using the AI. This is the linear interpolation between the two endpoint coordinates in simple way. Here we have calculate the compress bearing, so the car icon face its direction to travel. Update moving marker, we have more design it sometime later. And here move camera smoothly with the marker, and this bearing and tilt bearing rotate the map so forward is always off on the screen, and tilts create the perspective 3D effect like Google Map navigation node. Let's parse the distance string from API that we have called it. This is the parse distance and this is the parse duration. The direction API return distance as human readable string like 1 kilometer, 2 kilometer, and we convert meter kilometer if the unit is meter. And similar for duration as well. During string, duration string can be 1 hours, 20 minutes, 45 minutes or 2 hours. We use the regex to extract hours and minutes separately, and then add them together as total minute if minute for arithmetic in the countdown. After that, we'll update the moving car marker on the map. Call every 16 milliseconds from the animation time. We remove the old moving marker and add new one at the interpolate position. Rotation makes the car icon physically rotate to face its direction to the travel line, and this heading marker rotate to the face direction to travel. This is the pivot, and this flat true make rotation work correctly on the map, and this replace the old moving marker with the new one at the update position. Now next will be the bearing calculation. To use math.py you need to import the dart.math. Okay, this bearing calculation compress direction from point A to point B in degree. This use the standard spherical geometrical formula. Hover sign variable, we need this so the car icon rotate to face its direction of travel. Okay, this distance used only for normalizing progress along the route, not for displaying real time distance, real world distance. Okay, after that, now main things will be start. Car icon for moving instead of marker. First let's import the dart.ui, then I will start to explain why car icon instead of custom marker. Google Map SDK is only accept the bitmap descriptor for custom marker icon. We draw the car manually using the Flutter Canvas API. API used by the custom painter, then encode it to PNG byte. Why canvas instead of PNG assets? Because we draw it programmatically, which means we have the liberty to change its size, color, shape at any runtime without needing image failure. Here we have defined the size, and record all, draw call, canvas, color, and this is the shadow, and this is the car body, and this is the wind screen. Front top wind screen at the top of the icon. The top of the icon face the direction of the travel, and this is the 4 wheel. And we have convert the canvas recording into the PNG image, then into the byte that bitmap descriptor dot from byte can consume. By this way, we have designed the custom marker icon as a moving car. Now, generic marker builder share helper for building the current and destination marker, which is a simple circle with text at the center and background color. We'll create the marker bitmap custom circular marker icon for current location like U to display U, and the destination custom marker icon. Here we have draw fill circle with a white border, then overlay the first letter. If U, then we have overlay with the U letter. Otherwise, we have overlay with the first letter of the destination name. Just like if you set Nepal, we will display N. If India, I. And if United States, U. Like this, first letter of the label. Using the text painter. Text painter is the Flutter way of measuring and painting text onto the canvas. Here is the color label. We have set it the size. Draw the circle. Inside this circle, we have overlay. This is the white stoker border around the circle. This is not this. This is the white circular border, and this is the center, the first letter of the label inside the circle, and this layout measure the text required before calling the paint. After this all, we have completed almost everything. Now we need to clear the route. We need to clear route and bottom panel. Okay, we have clear the timer, we have clear the route info. At the bottom, reset everything route related and back to the initial state. We must cancel the timer first, and without this the timer keep firing after the route is clear. At the bottom panel, and here we have remove only the destination and moving marker, keep the current marker. Last, we have disposes, then we will create the provider. Void dispose. Okay, let's dispose it and animation timer dot cancel. That's it. After cancel the timer in the dispose to prevent memory leakage. If we didn't do this, the timer callback will try to update the state after the notifier is destroyed. Okay, last we have required the provider to call it. First, let's call the map provider. Okay, here in map provider, state notifier provider wires map notifier plus map state together for Riverpod. Any widget can watch this provider with the ref.watch map provider to get the map state of the call method. Here we have required the place service provider, direction service provider, location service provider. Where its service will already created in here. Let's set this service in the provider. This is the notifier. Before notifier, we have required the service provider. We have required this 3 service provider that we have created in the service file, and let's import the service file. These are the Riverpod provider that create the single instance of each service. This is for place service, this is for direction service, and this is for location service, and each service and make it available anywhere in the widget tree. Just like think of the provider like the global dependency injection container. We pass the API key from the app constant, so service doesn't hard code sensitive data. We have call it on everywhere in our app. Now let's work for the UI part. I'll move this map screen inside the screen folder, and in screen folder here we have required the floating action button, we have required the search bar. First I'll make this stateful widget to consumer stateful widget, and I'll call the map provider here finer state ref.watch map provider. I think I will add this provider inside the notifier, that's why it will not available. It need to be defined outside the notifier, that's why it will be not available. Map provider, now it is available, and if we require the notifier, then I'll also create it ref.read map provider.notifier. Then we'll call this provider and notifier inside this map screen on everywhere. Okay, I'll remove this and I'll add and inside this Google Map I will add remaining parameter that will be required. If you can see, I have set initial camera position. I'll define it at the top. Okay, this is the current map type. I will add one button here. From toggling this button, we can change the map to the satellite mode and the street mode. Okay, and we need to import the f constant for the map style. Now first I will initialize the camera position at the top. Here I have initialized the camera position, and I have also set the map type. Initially we have displayed the normal map type, just look like this. After toggling the button, we will change to the satellite mode. Okay, first I'll define here the one floating action button. Okay, this floating action button for my current location. You can see if I click it here, the map will move to my current location that I have set it here. If you are first time, then go to the location. In custom location, you need to set your current location, otherwise it will defaultly show the California, Los Angeles like default location. Okay, after that I'll edit here another button for map structure. Okay, this is for map type. On map type button, we'll call this button at the top, and I'll just set it toggle it. Default initially show the map type dot normal. After clicking show the satellite mode. Again if click back to the normal. Save it and let's try it. You can see this is the satellite mode and this is the normal state mode. Okay, another things that we have required here, that will be the circular progress indicator and the search bar. Simple circular progress indicator. If state.is loading, then show the circular progress indicator. Now we have required a search bar here. Inside the widget, I'll create another dot file and give name search result dot. Here I have first create the stateful widget. Here inside this location search bar, I have first create the stateful widget. Here I will define the controller and focus node, and I'll call the place result. This text field editor manage the text field content programmatically. We use to read the current text, set the text when you just select the suggestion, and clear the field as well. Focus node is used when we select the suggestion. Without it, we will have or rely on the user tapping. Elsewhere must also be disposed. Now, in suggestion, this is the current autocomplete result, list of current autocomplete result. This is the timer, header pending, and so the spinner inside it. And first I have dispose is when we have complete one, and before we start new one, we need to dispose it. Inside the on change, it call on every keystroke without debouncing. Will send an API request for each character type, very wasteful and potentially hitting the rate limit. Debouncing means wait 400 milliseconds after the user stop typing, then send one request. If the user type another character within 400 milliseconds, we cancel the present timer and restart the countdown again. By this way, it will hit less amount of request in the API. Here, after that, we have cleared the suggestion immediately when the field is empty. No API call needed here. After we have empty it, we have start the new 400-second countdown. If no more typing happen before it fire, the callback execute and calls the place API autocomplete. First, show the spinner while waiting for API. We have show this spinner inside the text field, and then we will read ref.read, get the current value of the previous value of a provider without subscribing to the future change. And we have update the local state with the API result and hide the spinner. After that, in onSelected, it will call when the user tap on the suggestion from the drop down list. Then three things will be happen. First, put the selected place full description into the text field, dismiss the key store and hide the suggestion list. And third, tell notifier to resolve the place ID lat long and draw the route. This is the process of the onSelected. Let's import the map provider and place service provider right here. This dismiss the keystroke, this hide the drop down, this hide the drop down list, and this last ref.read give us the map notifier instance, so we can call this method. After that, we'll call when the user tap on the X button in the source field, means X button means clear button, then we'll clear both the text field and map route simultaneously. After that, this remaining all are the UI part. In the source field, we have record the controller, focus node, loading, on change, and on clear. If user source, then this suggestion list will be appear. This is the simple text field. In the suggestion list, we'll make the one expandable list view. Inside this list view, this is the container. We have passed the shadow, and here we have set the item count, the length. We have display all the available suggestion. We have not set it the limit. If you want to set the limit, you can also achieve it. Here, one thing before going to the suggestion list, I will make you one thing clear in the text field. Here in the suffix, it will be happen. This suffix is the conditional, which either there will be three condition. First condition, a circular progress indicator while the API call is in the flight, and second, a clear button, X button, when there is the text in the text field, and third, nothing when the field is empty and not loading. You can see padding, circular progress indicator, controller dot text, otherwise icon button, which is the clear button. And now in suggestion list, I have already make it clear. In the counter list, we have showed all the available suggestion that will be available on the Google Map Autocomplete API, and make list view take only as much height as its contain. Okay, separate builder adds the things divided between items, and in the list view we have display the icon, location icon. This is the static icon. In the text, we have show the primary text, main place name, just like Eiffel Tower. Okay, in this primary, in suffix we have show the secondary text, area, city, country. So in the gray below the name, you can make it clear when search bar is working. In on tab, you trigger the unselected in the parents, which fill the text field, hide the drop down, and kick off the route drawing flow. Now I'll call this inside my map screen. This is my source bar, and I'll import it from here. Now I'll save it and I'll restart my app. Initially it will show this location. Okay, I'll again restart it. Again, no provider scope found. Let's go to the main dot and wrap this my app to the provider scope. Okay, save it and restart again. Now everything will be solved. Okay, everything is perfect here. When you click on the get my location button, the map is moved and show to the current location, and here is the location source. If you can source the some place like Kathmandu, then circular progress indicator will be appear, and after location is found, clear button will be also appear. If we select any place here, then the camera is moved and marker is start and the route is start to draw. You can see before draw the route, it show the circular progress indicator. You can see this is the car that we have designed it manually. You can see the car is moving. Until the car is moving, I'll make one thing here that will be the info banner. I'll create another widget here and I'll give the name of this widget called distance time banner dot, and until now our car is moved to the destination. You can see this is the custom info window. You can see Kathmandu will be appear here. You can see Kathmandu, Nepal. Here in the distance time banner, it will be simple. We have was both the route info and remaining field here. We have just call it here from the provider that we have created, and after that we have used the remaining if available, otherwise show the total from the route info. Simple, that's it. And we have displayed these two distance and time here in the info tile, and this info tile just return the icon text. I'll save it and I'll go to my main screen and I'll restart the app. Then if I search some place like Surkhet, then it will not create the route, it will only navigate to the Surkhet. Can see. Then if I get the current location and then if I click some place, then it will draw the route. Can see. Okay. Now the car is on the way to reaching to the destination. It will be perfectly working each and every navigation. Now this is the error banner. We'll call it here if it will show the error banner instead of the white screen. And distance time banner, I'll forget to call it. Okay, you can see the banner. Now if I clear it, then route is also clear and this banner is also clear. I will complete each and everything that will be required, and we have completed each and everything that I have presented in the demo. I'll restart the app and I'll show the feature is everything is working or not. This is the satellite mode, which is perfectly working. You can zoom in, zoom out. You can see everything is perfect. And if you go to the current location, then this is also working perfect. This is the custom marker. Say this is your current location. And if I source the any place, then it will draw the route. It will hold for 2 second delay to start to drive the live location. Then it will start to drive and it will show the remaining time here. Initially it show total, and after the car is start move, then it will change to the remaining, and time and distance will also update at the time when marker is move ahead. Marker means this car is our custom marker that we have designed, and this is the Kankre where it's show in the custom info window. By this way, we have achieved each and everything here. I have already demonstrated. If you didn't get your current location and just search any place just like Mumbai, then it will directly show the Mumbai instead of creating the route. Okay. If you get your current location and if you search any place, then it will start to draw the route. Now everything will be completed it here. Okay, I'll stop it. You can see you can easily change it, and I'll clear it. Each and everything will be completed it here. If you want, I'll put the source code link is in the description. You can buy it from there. If you want to learn, then you can follow the tutorial and learn. After completing Google Map feature, next we'll dive into the OpenStreetMap. You can see my simulator, only the white screen will be appear. This is my main screen and this is my map screen, where I have only display the stateful widget with scaffold in my map screen. You have seen each and every feature in the demo that we are going to implement in today's video. And if you have didn't watch my previous two video, this is the third tutorial of the map series, where in my first tutorial I have covered the Mapbox implementation in Flutter. In second video I have covered the Google Map feature, and this is the third tutorial of the map series, and where in this tutorial we are going to exploring the OpenStreetMap. If you want to learn more about map, then explore these all three and compare which one is sweet for you. Okay, before we start the video, I'll make you one thing clear. OpenStreetMap is totally free. You didn't need to pay anything for it. It is editable and it is open source map of the world, built by the global community of the volunteer throughout the contribution. Okay, this map is totally built from the open source contribution. Only one things that will be doubtful in OpenStreetMap will be the authenticity. Okay, other than that it will be totally free, it will work perfectly. Similar is other video. First we are going to add some package that we have required in today's video, and we have set up, if this package require any setup to integrate it on the Flutter. Okay, where we have required the Flutter map, we are using the lat long, we have using the geolocator, do, Flutter Riverpod. We are going to implement simple animation, that's why we are going to use Flutter animation. If you see the metadata of this Flutter map, it will mention that this is the Flutter #1 non-commercial AIM Flutter client. It's easy to use, versatile, vendor-free, full cross-platform, and 100% pure Flutter. Okay. And second package that we are going to use, latlong, which is the lightweight library for common latitude and longitude calculation. We are going to use this package to calculate the distance and to get the longitude and latitude. Third package will be the geolocator. Before exploring geolocator, I'll mention these two packages didn't require any setup. Everything will be included on the map. You didn't need to do anything in your environment. Okay. Geolocator, as you know, and if you have watched my previous two tutorial, we need to set up little bit to use geolocator in our Flutter app. You need to add this to use Android X and enable Jetfire in your Gradle property. Okay, I'll show you. You can see I have added. And next things, you need to set your compile SDK version at least 35. And another important things is the current update of Flutter. It will automatically detail. If you have any problem, then set it to 36. And for now, I'll leave as it is. And here another two permission, and this is the important to use this package in your Android. You need to add this three permission in your Android source main and Android manifest.xml file. You need to add this is user permission. After that, Android setup will be completed. Now let's dive into the iOS. In iOS setup, you need to add this key value pair in your iOS runner info.plist file. Okay, this and this three. If you want to check my iOS runner info.plist, I have added it here, and I have also mentioned it this environment for geolocator. And if you want to add this, you can add this 5 line of code, otherwise leave as it is. After that, our setup part will be the completed. Okay, no more setup is required for Flutter animation. After that, without wasting time, first we are going to integrate OpenStreetMap in our Flutter app. If you can see my main function and my app, I didn't do anything. I have just called the map screen of my app class. Okay, I'll go to the home screen, and first I'll display the OpenStreetMap here. Inside the scaffold, I'll directly call the body. I'll take the stack widget which takes lists of widgets inside the children. To integrate the OpenStreetMap, we need to call the Flutter Map. Flutter Map. The Flutter Map package display the OpenStreetMap. And main and important things before integrating OpenStreetMap, you need to know which you didn't need to set any API key. This is totally free. OpenStreetMap is totally free. If you want to know more about it, then search the OpenStreetMap in your browser and visit the OpenStreetMap and OpenStreetMap official documentation and learn more about it. Okay, explore more about OpenStreetMap, then you can get more info about OpenStreetMap. Now I'll close all the tabs. Where to display the map, we have required the tile layer. If you can hover it on the Flutter map, it mentioned that tile layer will be required. Tile layer, and this tile layer as the map image phase is 256 by 256 PNG square. By using this, we can switch between the standard OSM OpenStreetMap tile and the satellite image. Okay, we will implement this feature later. I will set max zoom will be 19. To display the map here, we have required the option. This option takes map option where we need to pass the initial camera position. Initial camera position takes the lat long. For now, I'll provide the sample lat long 28.23 and 84.45. Let's save it and let's see his map will be appear or not. Okay, you can see the error. To show the OpenStreetMap, we need to provide the URL here. For that, I'll create one folder inside the leaf folder and I'll give the name of this folder will be the core. Inside this core folder, I'll create another folder and I'll give name utils. Inside this util folder, I'll create the one dot file which is a app constant dot. And inside this file, I will store all the API and URL that will be required in our today's video. Okay, this is the base URL, OSRM route API and default map tile, satellite tile, and this is the default duration that we are called, and this is the initial zoom position, default zoom position that will be called in our entire app. If you can see, this is the OSRM base URL and this is the other URL that will be required. For now, we have only required this OSM tile URL, and when the video is going ahead, I will make you clear for which purpose remaining all URL and API will be used. Okay. Map screen in tile, it will request the URL template. In this URL template, I'll call app constant dot osm tile URL, and user agent package name, I'll pass the com.example.osrm flutter app. Let's save the app and let's restart. I think the map need to be display here. After that, everything will be perfect. In lat long, I'll set the my area lat long, then it will be easy to find out and it will be easy to see which area it will be display. This is the lat long of my capital city, and here in the open map, in the map option, I'll set the initial zoom will be the app constant dot default zoom. Okay, I'll save it and map integration part will be completed. When I'll restart, the zoom is set and it will show the capital of Nepal. Okay, you can see it will show the capital city of Nepal here. And another important things about OpenStreetMap will be it will show the native language on every country map. You can see here it will show the Chinese language, here it will show the Nepalese language, and after that it will show the Hindi language or English language. After that, we'll explore the remaining feature of the Google Map. First things, I will structure my folder. Here inside my leaf folder, I will create the another feature folder. Inside this feature folder, I'll create the three folder and three feature that we are going to implement. First will be the map, second will be the navigation or route, and third will be the search feature that we are going to implement. Inside this edge folder, we have required at least three folder or four folder to make structure our code. First will be the provider for logic part, and screen for UI part and component for widget part. We have required this similar folder in each and every file. Now let's start from the provider. Another things will be required, which will be the model. We have stored our model inside the model folder. I'll start from the model. Inside my model folder, I'll create the location state or model dot file. Don't worry about it. I'll make it as and everything clear before going ahead. Okay, first I'll import the lat long package here. After that, I will start to make you clear. First things, why we have required the model to manage everything related to the device GPS location. First we have requesting the permission from the user, will getting the initial position. Once streaming continuous position update is the user moves, exposing heading and the speed. That's why we have required this all the parameter here. And why this location state? This is the simple dart class. It holds the snapshot of the current location information. It will be the immutable and copy with pattern of the route state, where we have used this position to get the user current coordinate. Heading will be used to rotate the user location marker. This will be the meter per second speed. If required, we have used loading, otherwise it will be not required, and error will be the non-null when something went wrong. And main thing about it will be this copy with. This pattern will be repeated on each and every model. In simple way, it will be created a new location state with only the specific field change. When I will design the route state, then I will make you clear, because on that there will be the many component. By using route state, it will be easy for me to make you clear. Okay, after that, in provider I will create the location provider dot. Here inside this location provider, we will implement the logic class. It manages how location state change. It expand state notifier from the location state, meaning it's own and control the location state value. First I'll create the one class and give name location notifier, and I will expand this location notifier from the state notifier, and I'll use it here the location state that we have defined in the location state model. Okay, before that I'll make you clear one things, why we have required this state notifier. We use the state notifier because location is asynchronous and change over time. State notifier let us start with the loading state. It will update the state when permission is guaranteed. Stream new position is the user move. It will handle the error just like the GPS off, permission denied, and many more. First, we will hold the reference to the GPS system subscription, so we can cancel it when the notifier is disposed. It will be very important. Forgetting to cancel cause memory leakage or battery drain. That's why during code and during implementing feature, we have also focused on the app performance. Here inside the location notifier, I will initialize the init, where this is the entry point for the entire location flow. It run once when the provider is first created, and mark async because permission check and GPS call are async. For that, I'll create the future function and I'll make it void, and I'll give the name init. You can give any name that you want, and I'll make it async. Inside there, we'll start to code for the entry point. First, we'll check the permission here. If we can't get the permission, we'll update the state with an error message. This UI will show the error banner with location permission denied. We'll create the location permission later. In step 2, this is our first step. In next step, we'll get the one-time current position. Here we'll get the one-time current position, and this is faster than waiting for the stream for start, and we'll set location accuracy will be the high. After that, we'll update the state with the first position that we get, and we'll set each loading become false because we have get the first location, so the loading overlay disappear and map start to display. And wait, we have create this start stream as well. This will our third step. We will start continue streaming for the real-time update, and in case GPS might fail if the device in the airplane mode, indoor, or if they didn't get any location. Okay, outside that init function, we'll create the another function which is called start stream. After getting the first position, we start listening to the continuous stream of the position update. The main things behind stream and future, which is in future one value then done, like get current position. After we have get one current position, it will done. In stream, it will multiple value over time, like the river of data. We will need to get a data to show the entire cycle of the river. Get position stream return the stream position that keep emitting new position whenever the user will be moved. Here, this distance filter will be the main thing, key things here. Distance filter 5 means only emit a new position if the user have moved at least 5 meter. This prevent unnecessary rebuilding when an user is standing still. If user is moved more than 5 meter, then we will update only. During long time, if user are standing on the same position, then we didn't build it. By this way, it will improve the app performance as well. Here, in every time a new position arrived, update the state, Riverpod will automatically notify all the widget watch location provider widget watching location provider, causing them to rebuild with the new position. It will be prevented from here to rebuild each and every position when and by getting new position, still even the user are on the same position. Here in init, I will mention it here the entry point, and in stream, this is the continuous stream, and after that we have require a permission, user permission. I'll make you clear in one sentence this check permission. What does this check permission function do? It will handle the complete permission flow of the app, even if it will be Android or iOS. It will return true if we have a permission, false otherwise. Only things. If you get the permission, then it will set true, otherwise it will set false. But there will be the flow. How we can get it? First, it will check the location service are enabled at the system level or not. User might have turned off the GPS entirely in the phone setting. It will be the case, and after that we'll check current permission start without asking the user. This prevents us from triggering the system dialog unnecessary. If user already give the permission, then why we require to ask them? If not, then we'll continue. Here, if permission is denied, here we have only request if not already denied. If already denied, then we didn't ask it. Here in try catch, here we have check again if a request is already in progress by catching the exception, and here we have wait and recheck the result of the progress. In simple one sentence, if you want to know about this function, this check permission function check the permission if user get the permission or not. If they didn't give permission, we will ask for the permission. If it will deny the permission, then we will return false, which means user didn't give permission, and will return something error message or something else. After we have initializing anything, where we have initialized it here the solve, then we always need to cancel stream timer in dispose memory leakage. It will cause the memory leakage and something else. After that, main things will be required at the end. State notifier provider. By calling this provider, we have access this location permission in our entire app. Inside this provider, we have required another things before displaying map feature, which will be the map controller provider, which is the one of the important things in our today's video. Here, before we start to code, I will make you clear about 2-3 things, which will be the map controller singleton, What does map controller do? Map controller is a Flutter Map API. It let us programmatically move the camera pin zoom from anywhere in the code. Then why we have required provider? I have again mentioned in our previous tutorial as well, but in short I will also mention it. The map screen create the Flutter Map widget. It brought the route notifier and source bar also need to move the camera. Without the shear provider, we will have to pass the controller throughout many layer of the widget, and we also need to store it in the provider, make it accessible from any widget or notifier. Using the ref.was, ref.read, we have using the same instance in different case. That's why Riverpod provide this feature easily. You can also get it by using another way as well, but this will be the one of the easiest and important. First, I'll create the map controller provider. This map controller provider is a change notifier internally. We register dispose, so Riverpod clean it off when provider is removed. Just like by hot reloading or app close, it will clean up the Riverpod provider register data. Okay, after that we'll toggle it to show the street view and the satellite view. That's why simple boolean state false OSM street map true satellite image, and we'll store it in a provider, so map controller or button and tile layer both share the same value. Last and another important things, map movement data extension let us add new method to existing class without subclassing. Here we add the move smooth to map control, so call site read like the plain English map controller dot move smooth. Instead of repeating in the raw move call with the default zoom everywhere, we will call it here. And currently it wrap move directly in one sentence. If you want to call it in the different screen, then we will use the same move smooth with same zoom position on our entire app. Here in the screen, I will move this map screen here, and in widget we will require a two widget, which is the custom marker, and another require will be the map controls dot. In custom marker we have required the two different marker here. First will be the current location marker and another will be the destination marker, where this is the UI part. That's why I didn't want to waste too much time here. I have already prepared the code for it. I'll paste it here and I'll explain which part work, which function, and how many marker that we have designed and how we can design it. First, here we have designed the three marker. First will be the user location marker, show the current user location with animation plus, and second will be the destination marker, so destination pin on the map when we have source, and when we will reach on the destination it will show the destination marker. And second will be the navigation marker. In our previous tutorial, in our first tutorial we have shown the custom marker. In second Google Map tutorial we have designed the one car manually. In third tutorial, in today's tutorial in OpenStreetMap, we are going to use the moving navigation vehicle marker. Here, starting from the double heading, this is the device direction. Heading is the degree, 0 will be the north, 90 will be the east, and 100 will be the south here. After that, use the animation controller plus, which will came from the controller plus animation, and here will be the single ticket provider state mixing, which allow animation controller to run smoothly. And this is the init state. Inside init state we have set the animation duration 2 seconds and repeat animation forever until reaching to the destination. After that we have disposed this initialization here to avoid the memory leakage. After that I have start the animation builder here to rebuild the UI every animation frame. I will return the stack. Inside this stack, first I will return the transform dot scale, which is the outer plus ring of the marker. You will make it clear when we have displayed this marker. This is the simple marker. By this way we have designed the marker. I have set the opacity, decrease the opacity while scaling, and it will be the circular and color will be the blue acid. Inner dot with heading arrow, rotate it based on the heading value and convert degree to reading by using pi. To using pi, you need to import the mat.dart. Inside this container, this will be the blue circle marker with navigation arrow. Simple. In destination pin marker, this will be a little bit complex as compared to the initial marker. In this marker, which will be the red destination pin show marker, you have as seen it in the demo, which include the circular red pin, white border, small triangle tail, and pop in animation. This will be the main red pin. Okay, here until here, this will be the main red pin, and it will be the location icon. This is the custom painter. We will use the custom painter to design and this custom marker. By using custom painter, I will show the custom triangle painter that we have seen in the demo, and we will explore it later. Appear animation, here we will appear, begin with this, duration will be the 300 millisecond, and this will be the curve. And here we have designed the custom triangle painter. This will be the simple, and draw the small triangle trail under the destination pin. If you want to know about custom painter, I have already prepared the video for custom painter. Then you can also see it in the path. This will be the triangle shape path. It will move to top left. This will design the top right, and this will be button center, and this will close the triangle. And this curve.draw path, draw the triangle according to this instruction. At the end, this will be the navigation vehicle marker, where it will rotate marker according to the direction and convert degree to the radius by using bearing. And this will be the container, background color, a shadow, the icon will be the navigation will be rounded. Simple. In map control, we have so the two things here in map control. First will be the get user current location button, and in map structure it will be the satellite mode or the state mode. Okay, and this is easy, where we have designed two simple button. I'll import the each satellite provider. We will design this provider to get toggle between two state. Here I'll call this each satellite provider that we have designed in the map controller provider, and I have mentioned it here. We'll use it to toggle between two state. Okay, in map controller here, I'll design the one control button. This will be the simple material button, nothing else. Okay, and in icon, if it will be the satellite mode, then we'll show the map rounded, otherwise show the satellite all rounded. Simple. Tooltip is satellite state map, otherwise satellite. In on tab, we'll toggle between these two state. Simple. And in get my current location here, we'll show the my current location as icon. Tooltip will be my location, color will be the blue acid. Here we will get the user current location. First we'll ask the permission, and that I have already mentioned it in the location provider and map controller. After we will get the permission from the user, then we will show the user current location by moving smoothly. First I'll save it, and I'll call these two button in my map. First, in my map screen, I'll convert my stateful widget to the consumer stateful widget. Okay, after that, first things that we have require, we need to make the map ready. Before we getting anything, first we need to make map ready. We'll call once by using the Flutter Map package when its internal state is initialized. Only after this point is it's safe to call map controller to move. Okay, we'll call the location provider and map controller that we will define it. Okay, and here after that, this is the edge case. GPS position arrive before the map finish rendering. Without this check, we will start at the default center and never move to the user. Okay, currently we didn't move any marker and we didn't have any button. When we will implement the get user location button, it will move. First it will show the current default location, will show this default location. and then after clicking on the my current location, it will move and show the my current location. Next, I'll call the map controller is satellite and location provider that we have already created here. We'll use this provider. Before that, we need to listen it. After we have clicked the button, the camera need to move. To move the camera, we need to listen it at the current GPS position. Important things here, listen must be initialized inside the build context, not in the init state or inside the method. Riverpod require this so it can manage the subscription lifestyle correctly. It will auto center on the very first GPS fixed position. Mainly it will move the camera to user GPS position once it first become available. We have ready the map. We will call the provider and we'll move the camera. Now let's properly display it here, where I will add the controller and the initial center. I'll set the initial center location dot position, otherwise the default, and initial zoom will be the default zoom that I have defined 15, and map ready, interaction option, and in tile layer this will be the satellite and the tile URL. Let's save it. First we need to restart the app. Okay, everything will be perfect. It will show my location here, but until now there will be no any button here. Let's define this button inside the map. That's why we will call the stack here. After this map, let's call the my controller that we have defined, and it will show the two button here. If I click this button, then it show the marker here, but until now we didn't call the marker. But this satellite and state mode is working, but marker will be not appear until now. After this tile layer, let's show the all three marker that we have defined. When we have code for the route draw, then we'll enable it. Currently I will comment out it. Only show the current location marker. You can see now current location marker is visible here. When I'll restart the app, then it will show the marker in my current location, and when I drag the map on everywhere, and if I click on my current location, the map is moved and show my current location. Okay, it will be perfectly working. On the same way, if we have faced any error, then what will happen to handle the error properly? Let's show the one error message. If we get error message, this is from location.error that we will be set in the location state. When we'll get any error from the location, then we'll show this error, and route related error will be displayed later. After that, we have completed this part. Next, let's work on the source bar. Map will be completed. Now let's dive into the source. Inside this source folder, I'll create the three folder. First will be the models, and second will be the providers, and third will be the widgets. Before we start to work on the source feature, in navigation folder, I will make you one thing clear. First I'll create the models, and inside this model, I'll create the one dot file which is the route state, and here I will make you clear why we have required model, how copy width will work, how it will be immutable, how it will be important in the Riverpod. This everything will be repeated on the entire process. That's why first I'll make you clear. If we proceed, then it will be fruitful for you. What will be the main purpose of a model? I will make you clear. First, the main purpose, this file define all the data the navigation feature need or some other feature will be needed and in the one place. Currently we are implementing navigation. If we need a source feature, if we need a location feature need in the one place. Instead of having 10 separate state provider scattered around, we build everything into the single immutable state object. This is the core Riverpod best practice. That's why we will require the model. Why we will require? We will build everything into the single immutable state of object which will be required on the everything. Instead of creating or having 10 different separate state provider around. Someone is still confused what immutable state is. The route state object never changes. Instead, every time we need to update something, we'll create the brand new route state or something else file with the update value using the copy with. This copy with is always important. This make state change predictable, debuggable, and easy to track. And another important things about it, if we need to update anything, then we don't need to rebuild everything. Why we are required the separate state for notifier? Separating route state or separating source state or location state from the notifier logic part means we can import this state in the UI widget without importing the provider logic, which will be the clean, important, and the clear architecture. This will be the enum. Here I'll be the define enum. This enum is a fixed set of name constant value. It will be using an enum for status is much safer than using a string like loading, and because the compiler will catch typo and handle executive switcher class. Think of it as a drop down with a fixed option. This enum will be important during showing the this info banner where we will show the will ready, will loading, navigating, and will arrived. This ideal will be the no destination selected. This loading will be the route is being fetched from the API and spin show, and this ready will be the route loaded successfully and panel show distance and time. This navigation marker is animating along the route, and this cam arrived will be the mark reach the destination panel and the show success message. And this is the route class where we have defined the things that will be required. This is the list of route point, the complete list of lat long point, and from the route polyline. By using this list of route point, we will draw the route here, and this will show the current position of the animated marker on the map. This is the direction, the navigation marker show phase, and this will be the status. This will be the distance in meter, distance in second, and the current segment index, and this will be the error. If the OSRM API call fail that hold the error message to display, it will null, then this will be important and will display this error. And by this way user can get the actual things what will be happen in the background. And this will be the constructor. In simple sentence, what will be the constructor? If you want to, const plus default value means constructor. Route state with the no argument give us the value empty state that represent the ideal initial condition. This is what we will use route state notifier superclass in clean route. This first with the empty list, no route draw, and second will be the null marker not visible, null no direction. This ideal will be start in the ideal and not at phase, 0 start beginning, null no error. Until now everything will be the empty. And main things this is copy with. The concept copy with pattern is simple. This is the most important pattern in the Flutter state management because our state is immutable, final field. We cannot do like status.state or something dot status is equal to navigation status dot loading. Instead of this, we'll create the new route state with the updated field, and we'll use this copy with method. State.copy with feature. If you need, we can only access one, we can access two, we can access all. This will be the main married point of using copy with. Any field you don't fast copy with, keep it the old value. By this way, I am hoping you will clear about why we are using this, what is enum, and what will be the class, why we are record the model. After that, I'll dive into the source feature, and then we'll back to this route feature later. Inside this source model folder, I'll create the one dot file and I'll give name source model dot dot. Here we will require the same pattern of data. you can name it source model, or I think suitable name will be the place model. In source we will show the place. Display name, this is the place model class, where lat-long is the class from the lat-long2 package that hold the latitude and longitude feature, and Flutter Map use this type of natively for all the map coordinate. This display name show the name like Nepal, India, Pakistan. Along with the country name, it will also show this area name. And this is the shorter name. This will only show the shortest name that will be available, and both of these are human readable version. This will be the lat long. The geographical coordinates of this place use is to drop the marker on the map and calculate the route. And this type and icon, this is type is the category, if this place will be the restaurant, hospital, path or something else, and this will be the icon. If this icon is available, according to this type it icon will be shown. Okay, and this is the factory constructor. A factory constructor doesn't always create the new instance. It is the standard Flutter pattern for parsing JSON into the model. We name it from JSON by convention. The raw nomination JSON for one result look like this. This will be the cast of string dot JSON decode give us dynamic. Cast to string since dot JSON decode give us dynamic, and we'll generate the short name ourselves using the private helper method. This lat long return the latitude and longitude. This is the type. It will show the type of the place. Here we have extract, how we have extract the shortest name. This is the private helper class. This is the static method. It's belong to the class, not to the an instance. We mark it private using this underscore prefix before the name, because it is only used internally by from JSON. First we have split the every comma to get individual address, which make it clear. And if there are at least two parts, combine the first two with the comma, and then we'll trim it and remove any leading trailing white space around the edge part. Otherwise just return the single part we have. This is the place model. In provider, we'll code how we will get this place. Source provider dot dot. In source provider, we'll use the DO. Why DO? DO is the HTTP client. We use it instead of Flutter default HTTP package because it is the built-in support from the base URL. And here we'll create a DO as a Riverpod provider, so the same DO instance is shared across the whole app, which is the singleton pattern. And create a new DO object, and on every source we'll waste memory and ignore our share config. Here we'll stop the waiting if server doesn't respond, and we'll stop waiting if data doesn't appear in 10 seconds instead of showing loading long time. Here in the source query notifier, state provider hold the single piece of reactive state, the source string. Any widget that was this will rebuild when the user type. We keep it here, not inside the widget, so the query can read by other provider. Especially it will be used in the source suggestion provider, which will use below. And this is the autocomplete feature. How it work? Widget type source query provider update. First things. Second, this provider was the source query provider, so it rerun automatically. Third, it will call the API and return a list of placeholder object. And last, the widget use dot when loading error data to reach edge stage. Here we will use the guard. It will don't hit the API for very short query and save unnecessary network call. If the length is less than 3, then we will hold on it. The text length with more than 3, then we will start to show the suggestion. By this way we will save the unnecessary network API call. And here this is the endpoint. It will return an array of matching place, where I will filter only show the list of 5 place, maximum 5 place, and address detail which include the city country detail in edge result, and it responds the data is already parsed as the dot list of DO. And in exception, and we will show the network error, timeout, or non-200 response all throw due exception. Return this empty instead of rethrowing, so the UI show the no result gracefully. And last, after this all the things, we will require the select provider here. After the source provider in, we have required the selected place provider. When user tap on the suggestion, we store the full place model here. Multiple feature, route, fetching, map, camera, info panel, all read from this single source of truth. No proper drilling needed here. After we have already prepared the model, we have the logic, then we will call this logic inside the widget, which will be the search bar widget. Here in search bar widget, we will design the one search bar and the suggestion list. Here in the search bar widget, I have mentioned we are going to do two things. One will be the search bar and show the all suggested place here. We have required the text reader because we are going to using the text field. We have required the focus node. It will let us dismiss the keyword to on place selected, and we have required the debounce. It hold the debounce time, and initially we will set the show suggestion false. Initially it will hide the drop down, and in dispose, after creating the controller, I will dispose is all. Always cancel the timer and dispose controller to avoid memory leakage that I have mentioned many times in this tutorial. Here in on-chain, there will be the 2-3 problem. If we fire the API call on every single keystone, then the performance is decreased. Just like if we source one text and we are going to show the list of suggestion place. If we type the two text, then we will show the all suggestion list place suggestion. If we type 3 text, then we'll show the all question suggested available on this text. Then it will decrease the performance of app. Instead of this, we'll find the solution. We'll use the debouncing. We'll cancel the previous timer and start the newer 400 millisecond ones only after the user stop typing for 400 milliseconds. After user stop typing in any text, then we will hold 400 milliseconds. Then only we will show the suggested place, which trigger the API call exactly once after user stop typing, and this will be start to call after user type at least 3 character. We are start to showing the drop down only after user typing the 3 character. In on-chain, we'll call these things. In on-selected place, it will be easy. After we have showing the suggestion in on-selected place, call when user tap the suggestion list. This is the glue button search, routing, and the map. Once tap coordinate, 3 separate provider will be called. Here, it will fill the text field with the name. It will dismiss the keystone, dismiss the keyword, and suggestion will be false after user selecting any place. And we have required the selected place provider. Then it will start to draw the route after user selecting any place. Currently I will comment it out because we are not implementing the route feature. After implementing route feature, I will enable it. In clear source, we will reset all related state and back to the initial value source text selected place, and the draw route and all clear together so nothing's get out to a scene. Here in suggestion, every time suggestion load fail update, this widget will be rebuilt, and this is simple text field. Here is the text field, and we will call this text field here. In suffix, there will be the clear icon will be here if there are text, otherwise this will be empty. This is the border, and I'll set the padding. This is the suggestion list, only render when the show suggestion is true. After user typing more than 3 character, we will show this source fail or try again. If we get any error in this suggestion.when, it will call 3 things. One thing will be the loading, error, and data. Loading show the spinner while API is in flight, and error show the friendly message due exception is already cached upstream, and data render the list of result, and it will show in the animated form. A style fade slide in with the small delay for index. This is the suggestion list style icon. Maps a place OSM types string to the relevant material icon. The default cast cover street, city, landmark, etc. If we show the restaurant, cafe, then we will see this icon, hotel related icon, hospital. Otherwise in default we will show the location icon, and this will be the on tab on this list style means the list of suggestion, and this will be the icon, short name and the display name. After that we'll call it in our map screen. Okay, map screen, I'll call it and I will demonstrate it. How is it look like? We will show the search bar at the top and I will show it search bar here. That's why I'll set the padding top dot padding 12. From top we will add the padding 12 and display the search bar widget. I'll import the search bar widget and I'll save it. Now search bar will be appear here. Before that I'll restart the app. If we implementing new feature, we need to restart the app. Okay, now search bar will be appear here. Let's try to search any place. I'll search the Kathmandu. If you can analyze it, currently there is no any close icon button. If I start to type, then clear icon will be appear here, and when I will stop to typing, then it will delay the 400 milliseconds, then only it will start to show the list of auto suggestion. I will type it, you can analyze it. KTH, you can see until I have typed, it will hold it. After I have complete typing, then only it will show. You can see it will show the list of place in the native language. This is the Nepali language. I'll show you by typing another. I'll search the Mumbai and let's see, it can show the Mumbai. I have typed the exact name, that's why it will only show the one place. By this way, let's search the Mumbai and the camera is moved and it will show the place. And if I click on the get user correct location, the map is moved and the icon is moved and get back here, and location source is also working. Now only one things will be required. When we search and select this place, the route need to be create and it need to be simulate. We have already created the model inside the navigation. Next, let's create the provider and the widget. I'll create the provider folder for logic and the widget folder inside the navigation for component. In provider, we have required the route provider dot inside this route provider we'll code for draw route, a simulation and many more. Here we'll create the route notifier. State notifier is used instead of simple state provider because routing has a complex logic, async HTTP call, timer, math calculation, multiple step, state transition, all the logic live here. Keep the UI clean. That's why we are going to use the state notifier instead of state provider. Okay, I'll create the class and give the name route notifier, and I'll extend it from the state notifier using the route state. And we have required the three things here, which will be the ref from the Riverpod, timer which is from the dark.async, and this is the super class start with the ideal empty state. Now we have required the fetch route in OpenStreetMap, in shortcut OSRM. In open source routing machine, OSRM is a free routing engine that use OpenStreetMap data. We send 2 GPS point, it return the best route path among them. URL formatted, and note OSRM use lat long order opposite to the Flutter lat long. Without wasting time, let's start to fetch the route. First things, we need to fetch or draw the route after user click list of suggestion. If you want to know what does fetch route do in one sentence, it will draw the route between the user current location to the destination. This is the only one things it can do, but it will be the multiple steps behind it. I'll try to make everything clear here. If location and destination is null, then it will return empty. It will enable and to draw the route without the current location and the destination location. And inside this try cache, this will be the URL where we are use the OSRM base URL, latitude, longitude, and destination lat long. This overall tends to false means give us every point on the route, and this geometric equal to JSON means GeoJSON means coordinate a GeoJSON in the form of array, and last steps tends to true means turn by turn instruction means it will give the route turn by turn, and this will be the response. We'll get it from the URL HTTP package. If response dot not 200, then it will throw the error, and from JSON we'll decode it and we'll start to the route and code two things. GeoJSON codes are latitude and longitude. If we get both route and code, destination and the current location and destination, then we will start to draw the line, the polyline, to draw the map. And this is the navigation marker. Start at the origin, status will be the ready, and this will calculate the distance and the duration, where after route is completed at the end banner it will show the time and distance to complete this path. After we have getting the route, then we will start to navigate it from the current location to the destination point. Animate marker along the full route. Here in animate marker along full route, simulation drawing along the route by moving the marker step by step. The problem with the raw route point, they are unevenly spaced. In the curve it will be the short path, in the straight way it will be the longer path, which will be the unevenly spaced. Some segments are 2 meter apart and some segments are 200 meter. So the simple will convert it into the 1.4 trick, which will look the fast on highway and slow in the curve path. The solution will use the interpole path and will create the n evenly spaced point, so the marker always move on the constant visual speed regardless of the road geometry. If we didn't get interpole, then in the curve marker is moved slowly, in the straight path it will move too fast. The solution of this problem is building interpolate path with the uniform space. If we will check route point is empty, then we will return an empty, and if animate timer cancel, we will cancel the previous navigation here. This is the path and the total steps, and then we will build the new list of total step evenly spaced point along the route that I have mentioned. Initially step will be the 0, and in the step.copy with it will navigation status will get it from the enum, okay, that we have defined. And in the animation timer we have the time period where every mark animation duration, example it will be the 50 second or less, as tick we advance 1 steps smooth animation. And here this is the current steps and the new steps. Current steps will be the interpolate the point that we get, and next step will be the current steps plus 1 point ahead. And this bearing, it will calculate the compass bearing, so the navigation icon rotate to face forward. When route will different, then camera will also move according to this route. And we have also used for the progress bar in the UI, and we will increase it until reaching to the destination. After the marker is reached to the destination, then we will stop the navigation and and from the info banner user can also clear the route. After clicking the button, the route will be clear. Here we have complete the main two things. We will draw the route and we will simulate marker between the starting point to the destination, but we have required the helper class to achieve this feature. We need to convert an irregular polyline into the evenly spaced point, which is the interpolate path, and we need a bearing. How this uniform spacing work? There will be the 4 algorithm inside it. This will be the helper. Inside it will be the 4 things happen. First, measuring real world distance of every segment with habersign. The habersign is the algorithm that I have mentioned in my previous tutorial. If you want to know, then watch my previous tutorial. I will explain it in the Google Maps series. And next it will divide total distance by step, targeting spacing per steps, and it will divide each steps in the equal segment. And third, walk along the segment, placing a point whenever we cross the step bouncing. And last 2 steps, use linear interpolation for sub segment precision. First it will calculate the total distance, and then it will divide the distance into the edge piece, edge equal number of piece. Then it will provide this all to the start navigation, where navigation make it smooth. This will be the meter per animation steps. This result.add always include the start, and here advance and through segment until we find in the one that contain the target, and we'll increase it until we will get to the destination. And this segment progress means how far into this segment in our target, 0 to 1, 1 to 2, and the linear interpolation between the segmented endpoint. At the end we will always include the destination. To use sign, you need to import the dot.math. After that, last one things will be required, which is the bearing. And before that, I'll make you clear what is a habersign is and how we can calculate. Calculating the real world distance meter between the 2 GPS point, accounting the earth curvature, simple Pythagorean won't work on the shape. That's why we have used the habersign algorithm. And at the end, we have required the bearing. After bearing, we'll dispose everything. Bearing, it will return the compass direction 0 to 360 degree from 2 point to 2, and use to rotate the navigation arrow icon so it always face the road ahead. Formula, spherical trigonometry. If you want to explore it, you can know it about it. Otherwise, AI can do this type of tasks. You didn't need to worry about it. After that, we have cancel the timer, and last, we need to create the provider here. We need to call the provider here, state notified provider, watch the notify to Riverpod dependency graph, ref.watch route provider gets the current route state. Okay, and reviewed whenever state change, edge animation text and status change, etc. After that, let's call this route in the search bar as well that we have commented, and import it. And in the main screen, also on comment it, at the top, let's include the route and destination provider here. I have included the route and destination provider here. After that, I'll import route state, then error is gone. And another things that we need to call it here, it will be the camera follow during navigation. This handle navigation camera call on every route provider state change, just like every animation take, and keep the camera center on the moving navigation marker automatically. It will auto follow the animated marker during navigation on edge path. After that, let's call this handle navigation here and follow the animated camera during navigation. Let's save it and I'll restart it here. and I will search the one place here. When I will search it, first it will show the loading here, and after that it will draw the best possible route. I will sort it, it will show the destination, but a route is not draw yet. Let's see why. We will not call the polyline draw method here. Let's call it. This is the method to draw the polyline, and let's save it. Okay, you can see route is draw. If you can zoom, you can and see route is draw perfectly. Now only one things will be required here. We have required the info banner here. This info banner show the how many distance and how much time it will require to complete it, and start button will be also there. By clicking on this start button, we will navigate between this route. Inside this navigation folder, we have a widget. Then I'll create another dart file, and I'll give name of this is dart file with route info panel, and this is the one banner simple UI part. Here we have called the route and place and is navigation and is arrive. This is from navigation status. This is the enum that we have defined. Okay, and here this is the one container. We will set the color according to the navigation status. If is it arrive, then we'll set it green. Is navigating, then blue, otherwise blue asset. Similar in icon, we have set the different icon in and text according to the navigation status. We have set a different text. If arrived, then we have say you are arrived. If navigating, then we have show the navigating. Otherwise, if only route is drawn, then route is ready. And this is the button. If not arrive and not navigating yet, then we will show the start button. After it will reach to the destination, this button will be disappear. And here this is the close icon button. You can also close this bar, and you can also clear this all as well. And the status row, in this status row we have show the distance and duration. When it will start to move, then this distance will be changed to the remaining distance. From where we can calculate the remaining distance, we will calculate this remaining distance from the route status. Here we will calculate this distance, and this is the method for calculating distance and calculating and duration, and this is the method for calculating remaining distance and the remaining duration. We have display distance in kilometer and meter, and we have display duration in hours and minutes. If you want to know more about how we can calculate distance, duration, how we can calculate remaining distance, duration, you can watch my previous tutorial as well. From there you can get some extra knowledge, and you can also know how you can calculate. I'll save it, and only one things that will be remaining until we need to call this route info banner here in the main screen. I'll call it here after the map controller. You can call it anywhere where we can set it using the positioning. Before that, first I will set the route loading indicator. When route status dot loading, during this time we will say finding best route text in the map overlay. At the same time, we have also required this is OSM attribute. And last things, I will call this banner at the end. We have display the route info panel at the bottom, and at the same time, if we face any error, then we will also show the route error snack bar. Okay, you can see it will be appear. Currently in the distance, it will show distance and duration here, and here is the start button, and route is ready will be appear. When you click start, then the map will be moved and new marker will be appear here and start to move. Let's start. You can see new icon will be appear. This will be the marker, and here it will be the show remaining. At the same time, it will also update the distance and time. When it will reach to the destination, it will show you are arrived, and time and destination will be the reset. When you close it, then everything will be clear and it will back to the original position. I'll search another place and I'll show you clearly. First I will restart app where I have implement and another feature. Sometime we need to restart it to get the best outcome. From here you can also change the mode. I'll search another place around my area, which will be, I will source this place GGRETL Gagrital, can see, and the map is created. Okay, if you can see, when the map is created from here, it might be created directly here, but not. This will be the crossing path. The crossing path will only available here between the lane. That's why the map will create it perfectly. And I'll start it. After I have start, this start button will be disappear, and distance and time will be also updated. Then this progress bar is also updated. When it will reach, it will reset, and this is the street view, ads, and everything is working perfectly. When we close this, everything will be clear. And if you can and source the longest route, then it will also show the route as well. Okay, I'll source this place. You can see the route will be created by this way. The route will be created perfectly. I'll zoom out and show you. See, route will be created perfectly. To start the simulation, it will take too much time. That's why not starting the simulation here. If you can check, the route will be created perfectly on each and every navigation. By this way, we have completed the today's video. This is the last part of the map series where I have already covered the Mapbox and Google Map API, and this is the third, which is the OpenStreetMap. You can compare it and learn in the different way. Okay, if you want the complete source code, I'll put the source code link in the description. Okay, after completing Google Map and OpenStreetMap, at the end we will explore the Mapbox. I'm expecting that you have seen the demo what we are going to learn at the end of this video. I have explored edge and edge feature in demo to make you clear, and why Mapbox popular Google Map will be here, and it also provides some feature will be free, because Mapbox is one of the best alternative of Google Map, where it provides the 25k active user in free of cost. It provide each and every feature, and another good things about Mapbox is work perfectly on each and every feature. In OpenStreetMap, we have confusion about the validation. This is totally formed from the open source contribution, but Mapbox is not. You can easily find each and every feature that you have get in the Google Map. Only differences between Google Map and the Mapbox is Google Map cost will be depend on the how many data user can consume, how many load. It will depend on this, and Google Map provide the $200 credit for each month, but Mapbox is totally different. It will provide you the 25,000 active user per month. If more than that, then you need to pay. Here you can see this is my main screen, and this is the app currently look like. I didn't do anything until now. I'm going to start it from the scratch. Before we start to code, first let's add the package and set the environment for this package. In this video we are going to use this. We are not going to use Mapbox search. We are only going to use this package, this 6 package here. Okay, I'll open Ace package and show you is this package require some setup or not. DO and Flutter Riverpod is not require any setup, where Riverpod will be used for the state management and DO is used to get data from the internet. You can also use HTTP as well, but I'm familiar with DO. I like it. In this video I'm continue with the DO. Here after these two packages, this is the flutter.env package. If you can see it here, flutter.env package easily configure any Flutter application with global variable using .env file. And the main things about .env file will be, if you commit on the GitHub, this file will be not committed, and if you deploy the app, then this file is not deployed on the server. This is the one things of the .env file. And in this today's video we are going to use .env file to store our Mapbox access token. Just add this package and from here create the new file .env file. Here store your Mapbox access token. From where you can get your Mapbox access token, I'll demonstrate you. Didn't worry about it. Okay. First of all, go to your favorite browser and just search mapbox.com. Then you are landed here. If you are first time, then you need to create account here. This is totally free that I have mentioned. Create your account by providing this all the information. After you have provided this all the information, with the current time, Mapbox ask you to provide your payment info. But didn't worry, it didn't charge you until you have a 25,000 active user. After you have created the account, then I'll show you the screenshot. How does it look like the home screen? It look like this. Home screen look like this. If you are first time, then this part will be not there. Then remaining all will be same. From here, if you can see, a Mapbox SDK for mobile, it will provide 25,000 free monthly active user. After that, it will only charge you. If you only use map load for web, then 50k loads available. If you have used static style API, then 200k free tile request will be freely available. And if you want more, then and explore some other things about it. Okay. After that, only things that we have required from here will be the token. Okay, we have required the tokens. Default token will be required. From here, just copy it and paste it here. That is the only task that will be required in the Mapbox account. Other than that, it didn't require anything. If you have using Google Map, then it will require to enable many things, but from here, it will not require many things. If you want, just enable the read write during creating it. Other than that, and if you copy my token, I'll refresh it, it will not working. Use your own token, and I'll provide the complete source code is in the description. If you can buy the source code, then from there you can also get the token as well. Okay, after that, let's dive into the permission handler, geolocator, and Mapbox map flutter package. Okay, here I'll open the Mapbox map flutter package. Is anything required? Deploy iOS. Yeah, iOS will. If you are using the iOS version less than 14, then it will not work. Other than that, it will. Here it will mention that we need to configure this settings for Android and iOS. First, copy this two line of user permission and go to your Android manifest.xml file. Search it from here, Android app src main, or you can go it from here as well. Android app source main Android manifest.xml and add this. It will mention these two packages, but other package require this two as well. That's why I am adding it. We can follow the process step by step. First, copy these two user permission and paste it here. After that, in iOS, go to your info.files file. In iOS folder, go to the iOS. This is the leaf folder. Here inside the iOS, go to the iOS runner, and here is the info.files, and you just need to add these two key value pair. Here. Okay. I have mentioned each and everything in comment, okay, to make you easy if you get the source code. Okay. After that, that's it for Google Mapbox map Flutter setup to implement it in our Flutter app. After that, we are also going to use geolocator package to get user current location and some other stuff. Okay. Then we need to set up some environment to implement geolocator. First, we are continue from the Android setup. Here you need to add this in your Gradle property. First, go to your Android folder, and here is the Gradle property. If this two is not presented here, just copy and paste it here. Okay, and compile SDK will be at least 35. In app build.gradle, here you need to provide compile SDK at least 35. 36 currently, I think 42 is also available. I'm not sure. I'm providing 36. Okay, and user permission, same permission that we have already provided here. This is not required. Same permission we have already added. and access background location, copy this permission, and foreground service location, copy this user permission and paste it in your Android manifest file. Okay, easy. After that, here is the iOS setup. Next, and this is also easy. You copy this two line of key value pair and paste it inside the iOS runner input.vlis. Okay, here geolocator, these two. Next, inside your iOS pod file, you need to add this two and this two line, and this two is already there. You don't need to add it. Just add this 5 line of code here in your pod file. Here you just need to add it. Okay, that's it. And another things, also you need to also copy this key value pair and provide it here in your info.vlis file. I have already provided here. I have copy age and everything from here. I didn't do anything. When I have using any package, then I'll follow the documentation and it will provide age and every instruction. I just follow the instruction. Copy this line and paste it here. Then package setup part will be completed. Here until now we have 8 packages. We have set up the environment for this package. We have create account in Mapbox. We have get API key and we have store it in our .env file. Okay. After that, first steps, let's display the Mapbox here. I'll set the white background color. After that, I'll use the stack widget. We have require it later. That's why I'm starting from the stack. And map widget, this map widget is from Mapbox map flutter, and just save it. This is your first time, then terminate the app after adding the package and set up the environment and run the app again. But this is not my first time. Now it will working perfect. Mapbox will be display here. Okay, camera position, camera option, it takes camera option. Just remove this const keyboard from here and camera option. Here I'll set the zoom will be and just restart it again. Okay, now before map will be display here, first we need to initialize the Mapbox in our main.dart file. I have already made by main function async because setup need to complete before the app start. If you have not make it async, then make it. And widget flutter binding will be required. Widget flutter binding dot ensure initialize. After that, here why we have used async await here, it will be simple. Our setup need to be completed before the app start, and if setup fail, it will be invalid token missing or .env. We want it to throw immediately instead of crashing the app silently. Here outside this main function, I'll create the one function, future function, and I'll give this function name called this is void, which is called setup. You can give any name that you want, and I'll make it async as well. Flutter.env loads our .env file from the asset bundle. I have already added it in my assets. Okay, .env, you need to add it in the .env file. You need to add .env file in your assets. Okay, didn't forget to add it. After that, I'll use the await keyword and .env file store the sensitive value like API key that should never be hard coded in the source code or committed to present control that I have already mentioned. .env.load this all from the flutter.env package, and we'll call the .env file here. File name must need to be matched here. Okay. After that, we'll get the token .env.env, and from here we will get the token. I'll copy the name. We need to copy the same name from here, and it didn't allow the any space here. Keep in mind, that's it for initialization part, and I'll call it inside the main function. Okay, before completing it, I'll do one thing. I'll validate the token before passing it to the Mapbox. A missing or malformed token give the confusion like 404 error deep inside the Mapbox SDK. This checks surface the real problem immediately. Okay, I will validate it here with the clear message pointing directly to the .env file, and validate token always start with the pk dot. Okay, and secret token start with the ASCII dot. At the end of it, we'll set access token, register the token globally with the Mapbox SDK. Okay. Oh, it need to be the outside of this, and this must be called before any map widget is created. That's why we'll call it in the main app. After the map initialize as no effect, the map will show blank. Okay, that's why until some time ago our map will show the blank white screen. Currently the map will be shown it here. Okay, you can see. I will remove this zoom from here, and let's see. Now, perfect. After we have initialized and passed the access token, and we have set Mapbox set access token, then map will display. Other than that, only the blank screen will be appeared here. Now we have initialized it, we have set up it. Mostly integration part will be completed. One thing should already completed. We have integrated the Mapbox in our Flutter app. Now let's explore the other feature. First, I will structure my folder. I will create the one provider folders, and next I will create the one widget folder. I will create another folder service folder, and another folder which is will be the config folder. Last I will create the model folder. Okay, we have required this all folder. This is the best architecture of any app development, where we have separated the UI part, logic part in different folder structure. And in this camera position you can set your current location as well. If you want, you can easily set it. Let's set it center point. It will ask the coordinates takes position, and I'll pass my approximate longitude and latitude. You can pass your lat long to see your location. This is my approximate lat long, and I'll set zoom will be 2 and I'll restart it. Okay, perfect. It will show the capital of Nepal. I'm starting from the provider folder. I'll give the name called map provider dot. If you want, you can give any name that you have comfortable. And first question, why provider required here? Map provider is the bridge between our logic and the UI. Logic means map notified that we are going to use, and any widget that called ref.map. If you can follow the other Riverpod or state management widget, then we have used ref.watch, ref.read will automatically rebuild whenever the state change. No set state, no stream builder need. Best benefits of using Riverpod will be it will rebuild only those UI that will be required. If you have used set state, then it will rebuild all the screen every time. Okay, that's why we are going to use Riverpod here. Before using Riverpod, we will require the model map state or model dot. Here in map state, for someone asks, why do we need a map model file? Can we do it without a map model file? Yeah, you can achieve it, but without a model, we will store every piece of UI state is a separate variable. Map state is a single snapshot of everything of our map screen need to be displayed. Think of it like photograph. Every time something changes, we take a new photograph of the entire state. Riverpod compare the old photo with new photos and only reveal the widget that actually change. That I have already mentioned in why Riverpod question. Okay, the pattern we will use called immutable state. Simple. We have require is loading, simulation, show suggestion, and many more. I will create the model of all the state that will be required in our entire tutorial, and I will make you clear which things will be required and where. Okay, this is the things that we have required. We have explore, suggestion, current route, sometime later. This is all the things that will be required. I'm hoping you are familiar. Copy with lets us update only the specific field while keeping the rest on change. Okay, same thing will be repeated on everywhere, but this is the key things in the app development. If you rebuild when you have required a simple one state change, then if you have rebuilt whole screen, then the performance of the app will be impacted. After that, I'm continue from the map provider here. I will create the map notifier. Map notifier is responsible for all the map logic here. It extends the state notifier from the map state that we have created, which means it hold and manage the map state. Okay, class map notifier which extend from state notifier, and the UI never modify state directly. It call method on map notifier. Okay, every state notifier must call super with the initial state. That's why I'm also calling this here super notifier super from map state. And first, let's initialize the private reference that are not at the part of the map state but that will be useful. First will be the Mapbox. And these are the map SDK object cannot be serialized into a state. They live here the private field instead. Okay, this is the Mapbox controller. Similarly, I have create the device GPS map, manage map marker, the moving car marker, and the controllers the driver time. Okay, that will be required sometime later. That's why I have created it here. Let's start. First, let's make the map ready, and I'll give name called map ready. Okay, this will be the future function. I'll make it void and I'll give name on map created. From the map we are going to use Mapbox. I'll pass Mapbox as the parameter. First, I'll create the annotation manager before storing Mapbox and pass the below, so the layer render on the top of everything, which include the route line with draw later. Okay, if I set below, then it will be at the top layer. After that, location component setting enable the blue dot at the map that show the user real-time GPS position. Okay, just here if we set this, then it will show blue dot, which means the current location. And next things will be we'll initialize this location. Once map is ready, it immediately fetch and fly the user location. Second things that we will set the location. Here everything will be correlated. Calling on startup, get GPS permission and the current position. First we'll store the position privately because it used when building the routes but doesn't need to trigger UI rebuild by itself. We need to call it from the location service. Now we have required the location service. In the service folder, I will create the location service.dart file. Here in location service, we have handled the location service. Location service handle all GPS permission and position logic. Okay, it is the statics utility class, no instance needed. Just call directly. Keeping this separate means the map provider stay focused on the map logic and the location concern live in one dedicated place. I'll create the class and give the name location service. Inside this location service, first we have required the get current location. Get current location handle the full permission flow automatically. First it will check if GPS hardware is on. It will also check current permission status, also check request permission if not yet guaranteed. It will return the position or null if anything fails, and finally it will return null instead of throwing means callers handle failure gracefully. Okay, I'll make the static future function, and here I'll set the position and I'll give name get current location. I'll make async. For now I'll only do this, and we'll import this location service file here. First I'll complete the provider part, and at the same time if required we have continue on the service file. Okay, after the location we have required the fly to camera, which means when we have saw something or when we have click any button, it need to move the camera according to the instruction. Okay, which is camera. I have this fly to animate the camera smoothly to any coordinates. We have set duration around between 1000 to 1500. it will give natural feeling, pen animation, or we have set the custom marker here, and bearing 0 reset map rotation to north of, and this p0 reset map to the flat top down view. Okay, initially we have set the zoom 24. You can manually change it later as well. How the camera will be moved when we have search anything, and location search autocomplete feature show the list of place, and when we click, then this camera is moved. Now search feature will be required. Okay, if you can see it here, call on every keystroke in the search bar. We skip query shorter than the 2 character to avoid unnecessary API call. Just like if you just say, if we type A, then we didn't show any suggestion on 1 character. If the character will be more than 2, then we will show the suggestion list. For that, I'll create the one source service dot file, and here I will create the place suggestion is the sample data class. It hold exactly what we need from the Mapbox API. From the Mapbox API response and nothing more. We extract only the field we use, so that reset of the map never needed to parse raw API JSON. We need to extract it. We have search using the ID, name, full address, latitude, longitude. After this place suggestion, first I'll go to the model here, and I will uncomment this suggestion and import it here. Okay, where suggestion is in the list, that's why this will be the list of the suggestion. Here we have created the source service class, the Mapbox geocoding API to convert text into the place. This is what power the autocomplete. Same technology is Google Place API. If you have watched my previous tutorial, I have also covered the Google Place API feature. Source service. Here, first I'll initialize the DO from the DO package that we have added, and to get the suggestion autocomplete, first we have required the Mapbox token. We have fetched the place from the API. Okay, that's it for here. For now, let's continue. Okay, let's create the instance of the source service at the top of the file, final source service, and we have called the source service that we have created. Okay, that's it. Let's pass the things that it asks. Initially, 3 things will be required: query, proximate lat, and proximate long. Okay, now let's continue here. We have implemented the source, we have the camera movement, location, and we have already ready the map. During source, there will be the multiple list of autocomplete. After we have selecting the one, then we need to hide the remaining all source. Okay, this will hide the suggestion. Until now, we have not fetched the suggestion data from the API. Okay, now fetch it. This is the main flow trigger. User pick a place from the drop down. Order matter here. Hide suggestion, show loader, fetch route, and draw. This is the flow. First, when user put the some text on the text field and select it, it will hide the suggestion and it will start the loader, and in background it will fetch the route and it will draw it. After that, suggestion will be hide completely and loader will be disappear. This is the flow. Here, this is the main things. Place the name, store the place name, so search bar widget can display it without triggering on search again. Okay, this is fly to the location. First fly to the destination, so user see where they are going, and we have safely checked. We need to current position to draw the route from the somewhere, and here we have fetched the actual driving route from the Mapbox direction API. We have required the direction service. Here in direction service, similar to the source service, it holds the place source. Here in direction service, route result hold the complete route data we need from the direction API. At the same time, we have also stored the distance in meter and duration in second. Okay, at the raw number, we have calculate it later and formatted text during the simulation. We'll implemented it later when we have search and draw the route. At the same time, in the banner here we have display the distance of this location and expected duration to travel it. Similar is the source service, we have required the class here and class name will be the direction service. Oh, class need to be the outside of the class. Class direction service. Similar is a source service, we have required the DO and the token. Okay, same things will be required. I'll copy it from here and paste it and import the dot and DO and token. I will create the future function here, which will be the route result. Okay, and get route. Again, this will be the async. Inside this get route, we have required the 5 things, which will be the original latitude, original longitude, destination latitude, destination longitude, and profile. Driving, walking, and cycling. This is not required, but I have passed it. It maybe we have implemented in the next tutorial. Okay. Now let's continue here in the map provider and just let's import the direction service. Okay, we need to initialize it here. Final, which will be the direction service. To use the any class or service, we need to initialize it on the is function. I think name will be mistake here. Let's check the direction service. Okay, I'll forget to pass the get route. Name will be mistake here. I will correct them. Let's go here. Route will be the completed. And another things I will need to uncomment, which will be the route result. I will uncomment it, then continue from here. Only the 3 things required, then we have completed the logic part. These 3 things will be the draw route, create driver marker, and feed route bound. It will be short. I'll just completed it. Here in the route, Mapbox render routes using the 2 concept, which is the source and the layer. First I will paste it code here. Okay, this is the things in route. These 2 things will be the source and the layer. The raw GeoJSON data, the coordinate point, that will be the source, and the layer will be the visual style applied to the data, just like color, width, caps, etc. You always need both. A source with no layer is invisible. After we have creating the route, we also need to clear it. First let's clear the route in just 2-3 line. Route, clear route. Here you can see I have cleared the route. And same things will be required. Why I have not initialized it at the top? Because I want to demonstrate it. Everything we have created the one route and we have added it in the layer, and when creating the new route we will clear this previous route, then we have create the new route. Here at the top we have required the 2 things, which is route source ID and route layer ID. Just import the dark.async, then JSON encode will be working perfectly, as in everything is working perfectly. We have draw the route, we have clear the route, and now next things will be the creating driver marker. We will create this marker later. Now let's fit route bound. You have not clear about what it is, I will make you clear. Okay, fit route bound, calculate the bounding box of the route and animate the camera to feed the entire route with padding and around the edge. Means there will be the multiple corner here. During creating the route, it will fit and animate the camera. After this clear route, I will set this fit route here. Now only one things will be required. We need to create a marker. First display the route, then we will set it later. Before creating the route, let's complete the direction service and location service. Here in direction service, we'll use the try-catch Mapbox direction app API. Expect the coordinate is a semicolon separated, which is a lat long pair, original longitude, original latitude, destination longitude, and the destination latitude. Okay, and you can get this direction API link from here as well. This is just a Mapbox direction v5 Mapbox, or if you want to get it, then here in the documentation section it will mention age and everything. Just explore this documentation, then you can get it all. After we have source, the any place route will be created along with this route. Here will the banner will be displayed where it will show the expected distance and the duration. For that we need to formatted it, where distance will be represented in kilometer and meter if less than kilometer, and time will be hours and minute. Okay, that's it for direction service. Then location service is quite easy. I have already mentioned that in location service, mainly we will ask the location permission. First check the GPS hardware, check current permission status, request permission, and return the position. Okay. Here after that, stream for live location update, get live location, return the stream. It continuously emit new position is the device move. When the device move from one place to another place. Distance filter 10 means new position is only emitted after the device move at least 10 meter. Okay, if you can set it near, then it will be more smooth, but it takes too much time. That's it here. Update every 10 meter if you want to know it in once. And then last things will be the source service. In source service, two things that we are going to implement. One will be the source and another will be the location source autocomplete. Always use try catch. When fetching data, it will show the error message if we return any unexpected token. This proximity I have already mentioned it, and here is the query goes directly in the URL path, and Mapbox register URL encoding to handle specific character and non-Latin script like Nepali or any native language other than international. Autocomplete true means enable partial matching suggestion. Will show the 5 place in the autocomplete. If you want more, then set this limit. You can easily increase or decrease the limit. And here the API return the GeoJSON, which is a feature collection. Age feature GeoJSON feature collection. Age feature have geometric coordinate, which is lat long, and the place name. This name will be the short name and this place name will be the fully formatted address. And here we have written the empty list on any error so that UI degrade gracefully rather than crashing. Suggestion just wasn't appear if suggestion was not appear. Okay, I have completed main things. Now let's implement it in the UI screen. First, I'll make this stateful widget will be the consumer widget. To use the Riverpod, we need to make it consumer and we need to pass it the widget ref along with the build context. No, this is only the ref, and in main.dart, I'll wrap this with center, which is means we need to provide the provider scope here. I'll save it and it will be expected. We'll run it later. In the map screen here, let's call the map provider. I think one thing will be missing here in map screen. We have created map provider is missing here. At the top, I'll pass the map provider and call this map notifier. Then we'll call this map provider on the entire app. Okay, can see map state and notifier. Now in the map screen, First things, I'll pass the key, which is the value key, and I'll give name called map widget. After that, we need to pass the style URI, which will be the map state dot current style from map state. Okay. Next things will be the map created from the notifier dot on map created. Now let's run the app. You can see this blue dot is appear and how camera is moved. Perfect. Now we have required the one source field here. For that, in the widget folder, I'll create the one source bar widget. We have required the one simple text field, and on change and on clear and text will be passed from the main screen. And this on change call on every keystroke trigger the geocoding API during source, and this void callback when user tap on the X button like clear to clear the route and suggestion. Okay, this text receive the selected place from outside. Okay, when this value change, did update widget sync it into the controller without triggering new search. We'll use this did update widget when we have source. This did update widget is called when the parents rebuild the widget with the new property. We use it to detect when text value change from the outsider. Just like user select the suggestion and it sync into the controller. Means when we have type something just like NEP, then Nepal will be the suggested add below, and when we have click on this Nepal, this text will be appear on the text field. This listener only update has text from the clear button visibility. Okay, it does not call on change. And this set text silently is a utility method for setting text without triggering the source callback. In simple, not currently call external but useful to keep if we add a feature like paste from the clipboard later. This on change is name method reference we use with the add listener, and from this dispose we have dispose the controller when we have click on the clear icon, and remaining all will be the this will be the container, this will be the text field. In the clear button, in this icon button, we have clear the controller, route and suggestion. It will only show the clear X button when there will be the text in the field. If hash text is empty, then it will be not appear. Hash text is updated by the controller listener in the init state. Okay, and this on change here fire on every keystroke from the user. We read from the controller.text rather than the value parameter to stay consistent with how the REST widget access the text. After that, I will call it in the map screen. For search bar, we'll need it at the top. That's why I'll use the position where in our body we have already passed the stack it search bar widget, where we have required the two things on change and notifier dot on sort change. On clear, in on clear we have passed notifier dot hide suggestion and notifier dot clear route. Another things will be the text value, which will be the map state dot selected place name. Position will be the from top. We'll set it to the top padding plus 10, and we'll set padding 16 from left and 16 from right. Let's save it. Okay, awesome. Let's sort some place. I think it will working. Now let's display the suggestion part here. Below this source bar, let's display the suggestion. If map state dot show suggestion available, then show this padding. Show this position. In this position, we have required the suggested list. To display the suggested list, I will go to the source bar widget instead of creating another widget, and here I will create the suggestion list widget. In this suggestion list widget, simply we will pass the place suggestion here, and item count will be the all suggestion, but we have limit it from there. That will be the only 5. We have display the name and full address, short name and full address. Okay, this will be simple, and I'll call it here in the suggestion list. Suggestion will be the map state dot suggestion, and onSelected will be the notifier dot onSuggestion selected. Now let's save and restart the app, and let's try if this feature is working or not. Now you can see working perfectly, but I'll forget to pass the padding at the top, which will be the top padding plus 70, where 10 will be passed here. We need to show it below the search bar, same padding from the left and right. Okay, this will be, if you click it here, then the map is moved and the marker will be created and the route will be drawn. Awesome. Let's search another place, which is the lake, which is near around here. You can see route is draw and camera is moved. Route is perfectly draw. You can see how much awesome is it. Now we have required the one get user button here and the toggle button to show the satellite mode. First my location button, floating action button. In location I am going to use the floating action button. On press of this floating action button will be the notifier dot recent. Oh, we have not created the recent location here. I'll pass it in the map provider. Here at the bottom I'll pass the recent location. Simple recent location service dot get user current location and move the camera. Notifier dot recent location. In child I'll pass the icon, and icons will be the my location. I'll set it at the bottom. Map state dot current route. If it null, then it will be 190 from bottom, otherwise 110. Simple. And from right 16. In floating action button, elevation will be 3 and background color will be the white and foreground color will be the blue. That's it. And hero tag will be the location. After this button, if you can click this button, then it will move the camera and show the current location. And in my previous Google Map series, I have mentioned if you have new in the Google Map, then initially in your location, default location will be the California. You need to set your current location as a custom location. From here you can set, then it will show your current location. Otherwise it will show the California or something else as your location, default location. And after that we have required here the satellite toggle to change this map into the normal mode and the satellite mode. For the satellite toggle we need to pass the toggle satellite in our map provider. Here I'll pass the style, and in inside style I have passed each satellite will be the state dot current style. In Mapbox config we have passed the API, map API of satellite, street and some other. Here inside the config folder I'll create another file and I'll give the name Mapbox config.dot. We have required this style street and style satellite. Let's import it here and import this toggle style here. After that let's save it and the button will be appeared here. Let's try is the satellite and the street mode is working or not. You can see it will perfectly working. If you can analyze, it will be better than the Google Map, that I feel. After that let's display the route info card here. Route info card. First I'll create another dot file and give the name called route info card dot. Now this is just a UI part. I will copy it from here. I have just pasted here. For now I will let's keep them here. And in the map screen we need to call the route info card here. First, if what I need to check, if map state dot current route not null, then we'll display it. Sometime later we will implement this drive feature. For now I'll just make it empty. And last things that will be required in our map screen will be the loader. If map state dot is loading, then show the circular progress indicator. Container color black 26, child center, child circular progress indicator. I'll restart it and let's source the place. Currently it will show the default location that we have set it here, and if I click this get my current location button, then map is move, camera is move and show it in my current location. I'll source the Ghantaghar Chowk. I'll source this. You can see before creating this route, it will show the circular progress indicator. When route draw is complete, then progress bar is disappear and route will be appear here, and expected time and kilometer will also here. Clear button will be here, and drive is currently not working. We'll implement it later, sometime later. Okay, if I clear it, then this route will be clear. Okay, I'll source the Nepalganj. Okay, neighbor city, which is the city near around Surkhet. Here you can see this is the route. It will show 101.5 kilometer. It will take approximate 3 hours and 15 minutes, and route is draw perfectly. Now this feature is completely working. Another feature, let's work on another feature. That will be when we draw the marker and when we click on start button, then marker need to move here along with in edge navigation, edge direction, and camera need to move. To implement this feature, again go to the map provider here, and first things that will require create driver marker. Before creating the marker, first let's work on the marker. Here Mapbox cannot use the icon image name that doesn't exist in the current style. Then the solution is to register our custom PNG into the style first using the add style image, and then we will refresh it by using the point annotation option. We have display the custom marker here, not the default marker. To display the marker, it will be the easiest process. Here function name will be the create driver marker. We have also deleted the previous marker before creating the new marker one, and here we have load our PNG from the Flutter assets folder, build as a raw bytes. We need to add the type data to use the byte. Okay, next this is a root bundle from the service, Flutter service, and asset folder is here. Inside my asset folder I have the marker to PNG. If you can see, we need to design a very small size marker. This is, and the image size will be near 40 pixel by 60 pixel or 40 by 50 pixel. Other than that, it will cover all the screen if you create the larger image. After we have load the PNG, then we need to register the image into the Mapbox style here under the name driver marker. After this call, any annotation can reference it by the string name. Width and height must be match your actual PNG pixel width and height. Here I have set the width and height it here. Use the small image that I have already mentioned, and this null will be the content bounding box for the text inside the image. By this way we have displayed the custom marker instead of default marker, and we have loaded from the assets folder that we have already added in our popspec file. Okay, after this marker, when we click the button, this marker need to simulate, this marker need to start to move. In simulation, no, this is not a simulator, this is simulation. In simulation, when I'll give the function name called start drive, here when we click on the start button, it interpolate raw API coordinate into the many small steps. If you have printed, it will show this type of stuff. Okay, if you can see invalid size, this is the warning, and the map is easily displayed. Without interpolation, the marker jump between point visibility. We have used the 20 steps. We generate the 20 intermediate position between each pair of real coordinate, giving complete smooth movement. If you increase the number of states, then marker movement will decrease the speed and it will look like this smooth. Okay, after that, here in the simulation subscription, stream prediction fires the callback at the fixed interval where in 50 seconds, within the 50 seconds, 20 time per 50 seconds means 20 time per second, which match a smooth 20 fps animation. And we have update the marker position, we modify the geometry property, then we have call the update to push the change to the Mapbox rendering engine. Here in the S2 is the smoother than the Fly 2 for frequent small movement. Here is the pitch and bearing. 45 give a 3D driven perspective, and bearing rotates the camera to face the direction of travel. If we draw the core turning route, the camera is moved according to the edge navigation. Here we have calculate the remaining distance and time. We have calculate what percent of route is completed, then apply the percentage to the remaining distance and time. First, let's calculate the formatted duration and the formatted distance. Here we have display the duration in hours and second and distance in kilometer and the meter. Next, let's start the helpers. The helper will be the interpolates coordinate and the calculate bearing. Listener interpolates between the consecutive coordinates pair. Okay, for each pair of point A and B, we generate the steps intermediates point by moving a fraction t. Fraction t will be the 0 to 1 from A to B. And this is the helper interpolation coordinates and calculate bearing. We need to import math the dot, and at the end we need to dispose it all. Always cancel the stream on dispose to prevent the memory leakage. I think still one thing will be required, which is the stop. We have not stopped the simulation. Let's stop the simulation and create driver mark. Let's call it here. Now everything will be completed that I feel, and I'll restart. Go to the current location. Let's source the place. You can see it will be working perfectly. Marker will also appear here. Let's start to drive. Let's go to the route info card, and in route info card on map screen, let's enable this process. Okay, let's save it and let's drive it. You can see how much smooth is it. The map is moved on each and every navigation, and similarly the marker is also moving along with edge direction. If the way is straight, then it will move faster. If it will be curved, there will be more navigation, then it will take more time. Okay, let's try some another place. Longer distance. I'll remember this Guntiger. Okay, let's search it. Oh, if you can see, no, this is too much long distance. Let's search the shorter distance here. Let's search the Surkhet Bazaar here. It will show 8-minute distance will be required to complete, and distance will be 3.1 kilometer. Let's start to drive it. You can see time will also and distance will also update. Time will also update. It will show the remaining time and distance. Working perfectly. Each and every feature is working perfectly. Movement is also working perfectly, and time and distance will also update. Satellite mode and street mode is also working. Source bar is working. Camera movement is working. Route navigation is also working. Get current user is also working. Now we have completed each and every feature. It will complete it. You can see this is the satellite view. If you can source Kathmandu, then it will also draw the marker, and it will zoom out and show all the draw line. it will draw the line. If the distance is shorter, then higher zoom level, and if the distance is longer, then it will decrease the zoom level. It will work dynamically, not in a static way. If we source the near place, then it will increase the zoom level. If we have source the longer distance, then it will decrease the zoom level here. And if you clear, then marker is gone. By this way, we have implemented the Mapbox edge and every feature in our Flutter app, and it will perfectly working on both Android and iOS, where I have also demonstrated you by running this in my Android device as well. Okay, after exploring all the feature, that's it for today's video. We'll meet you on the next video. Okay, bye bye.